I did yellow yesterday, so I figured I'd do orange today. Try and keep it in the rainbow instead of dark and dreary black. But I know I told you guys yesterday that we were moving away from drawing triangles and all of those good things, but I lied, which is usually what happens. Today we're talking about real world situations and how we can apply the Pythagorean theorem. And one of the best ways to be able to do this is through the use of triangles, right? If we can draw ourselves a picture and kind of visualize what's happening, then we're able to set up our equation a little bit better. So we're not literally using triangles to solve it, but you will be drawing a little bit today. And I love pictures, so do your best on them. All right, so I'm going to do two examples. One will be just a generic one. One will be from the assignment that you actually have to do today. So make sure that you watch this video so that you have a free answer and you kind of know what to do. So have you ever heard of those questions where it's like one train leaves the train station at 3 p.m. and it's traveling 15 miles an hour, and another train leaves another train station at 2 p.m. and it's traveling 75 miles an hour? When will those trains crash and everybody die? Well, we're not doing a question like that, but it involves planes leaving an airport at the same time. So I'd like to think that they're a little similar. All right, so here we go. Here's example number 1. 2 airplanes leave the same airport. One heads north and the other heads east. After some time, the northbound airplane has traveled 12 miles, while the eastbound airplane's only traveled 16. Well, that's more, my bad. Has traveled 16. How far apart are the 2 airplanes then? So you can sit here and you can try and say, all right, well, I can guess which numbers go where, but you don't really know where to start. So the best thing that you can do for yourself is draw a picture. So that's what we're going to do. All right, we have an airport. In the midst of this virus, maybe one is going to Newark. I don't know. You're at New York City. One of the airplanes is going to Newark. And the other one is going to the other airport in New York. I don't know. I'm not creative. Anyway, this is my airport. It's a building with the letter A. And here's my watchtower where the guy who watches the airplanes is. Anyway, this is my airport. Let's make it prettier. There we go. Airport. Now, if you're not good at directions, I'll draw a little compass looking thing here. This is north. This is east, south, and west. Now that we have that information, we're good to go. All right. So here's our airport. We have one plane. That plane will be blue. It went north. Womp. So here's our plane right now. Don't tell Miss D. All right, we know that it went 12 miles, which is not very far, actually, at all. All right, and then we have another plane. It went east in this direction. That's 16 miles. So they want to know, all right, well, how far are those 2 planes from each other? Now, you might be so inclined to say, oh, I know this. This is so easy. 12 miles plus 16 miles is 28 miles. They're 28 miles away from each other, but you'd be wrong. So we're not going to do that because we know at this point that if you have a situation like this, where there's a right angle involved, you can use the Pythagorean theorem to help you figure out the distance between 2 points. So we know that plane blue is 12 miles away. We know that plane pink red is 16 miles away. And now we can plug this into the equation. All right, so we have a squared plus b squared equals c squared. A is 12, B is 16, and we don't know how far away they are from each other yet. But we do know that 12 times 12 is 144, and we do know that 16 times 16 is 256. So we just need to figure out what c squared is. All right, this is a total of 400. So we know that the area, right, if we're still thinking about this in literal terms of triangles and squares, is 400. But we know that the square root of 400 is just 20. So we know that c equals 20. Perfect. If you write C equals 20 on your answer sheet, you're wrong because it's not a general problem. It's a word problem. So you need to make sure that you write 20 miles. 20 miles is the correct answer to this problem. I don't think it'll be too bad for you guys today. Maybe yesterday was a little hard because I did never actually get to teach you this equation in the classroom. You guys had a video on Friday too. But you guys had a lot of practice yesterday. Some of you took like 10 hours. So I believe in you today. And this should only take you like 30 minutes max. I promise. All right. So that's one example. We're going to go to the next one. Let's make a little space. All right. All right. So here's our example from the assignment you're doing after you watch this video. All right. Now, some of them are going to be a little obscure, but I really believe in you and I believe in your ability to use just a little bit of common sense mixed with a little bit of note taking to help you figure out what is actually going on. All right. So here's the situation. A 10-foot, if you don't know what that means, know that it means foot, 10-foot ladder is leaning against a wall. If the foot of the ladder is 3 feet from the wall, how high up the wall does the top of the ladder reach? Round to the nearest foot. So automatically, since it's saying round to the nearest foot, you know that it's probably not going to be a perfect square. So, get out your calculators, or you can look at that nice video I posted on Thursday last week, because it's really going to be helpful when you guys have your quiz this Friday. But anyway, all right, we're drawing a picture. A 10-foot ladder is leaning against a wall. All right, so let's think. We have this wall. We're going to make it 3-dimensional to make up for the fact that my airplanes look crazy. So this is our wall. And we have a ladder leaning against that wall. Womp. And we know that the length of this ladder is 10 feet. So we'll plop that right here. This is 10 feet. Now, it says that the foot of the ladder is 3 feet from the wall. So the distance from the foot of the ladder to the wall is 3 feet. And then it says, well, how high up the wall does the top of the ladder reach? So if we have all of this information, what we're really looking for is a side length, right? We're looking up for that distance of the height of the wall. So we have two sides, right? We have our hypotenuse. We have one of those legs. And now we're just looking for that missing leg. And we have all of the information that we need for that, okay? So we get a squared plus b squared equals c squared. A is 3 feet, let's say. So 3 squared. We don't know what b is. Plus b squared equals 10 squared. 3 squared is 9. So 9 plus b squared equals 10 squared, which is 100. Since we're looking for b, right, and not for c, we're going to subtract 9 from both sides. And we get that b squared is equal to 91. If you look at that video, you know that 91 is going to be somewhere in between the perfect square of 81 and the perfect square of 100. So you know your answer is going to be somewhere in between 9 and 10, probably closer to 10. Right, so maybe like 9.6-ish, but I'm guessing, I don't know. So if you'd like, you can use a calculator, right? So the square root of 91 is going to be, I don't know. Let's find out. Hey Siri, what's the square root of 91?
The square root of 91 is approximately 9.53939.
9.5393. I wasn't listening. All right. Now they want us to round to the nearest foot. So if we're rounding 9.5 to the nearest foot, we know that we can say the wall is approximately 10 feet. All right. What I'm going to have you guys do tomorrow is you're actually going to have to be a little specific. You're going to have to round maybe to the nearest 10th or to the nearest 100th. So just make sure that that's something that happens. And you'll probably practice on IXL tomorrow too. We'll see, because I want to push back a different assignment that you had to do. So tomorrow will be solely focused on rounding things to the nearest 10th and 100th. Also, don't quote me on that because I don't know. But either way, this is your video. The assignment should be quick. I promise. It shouldn't be too hard. I promise. Help yourselves. It's not that bad. Bye. See you tomorrow. Guys, I just found out I could put a video in a video. It's a wrap. Wait until you see this masterpiece tomorrow. It's over. I'll see you tomorrow. Bye. I can make myself your whole screen. Oh my god. It's over. It's over. I gotta look good tomorrow. Bye, guys.